Hi everyone, welcome back to my channel. Um, yesterday or in the previous video, what we saw was we basically made a part model, right? So we basically made a part model as shown here through Inventor and Python. So basically using Python and Inventor API, we're able to drive the part model. So if I close, we didn't actually create the model itself, but we just created a part document object. So how did we do that? Just like a quick recap. We first we imported the win32com.client module, and then we gave it an alias as WC, and then we created an inventor object by helping Windows to connect to the or identify the inventor application which is active right now as by using the method get active object, which is part of the module for part of this module. And then using the documents and how to use the comms object, we were able to connect to the inventor documents collection. And within the documents collection, you had to define whether it was a part model that you're trying to create or an assembly or a drawing. And then here, using the add method, what we did was we basically added an inventor part document object here to the inventor. So it's in memory. So if you just run it now, run this code, you can either click this button here. I'm using Visual Studio Code, but you can use any text editor you want. So as you can see, we have created a space, or what we call as a model space. Basically, we are in the 3D model space here. So as you can see, a new part has been, or a model has been created here. Just the part has been instantiated. Next, what we would need to do is basically we have to choose one of the planes and start sketching. But before that, there is something called as component definition, so which we have to define, which basically is like a reference to the component definition object. So in order to find out what exactly is a component definition, let's go into the Autodesk Inventor API object model. Again, I'm using 2022 because this is an old PDF that I have. But if you want to get the latest one, you can just go and Google Inventor API object model 2023. And yeah, basically you'll find it in one of the links here. But I'm not sure if it has been released yet. But as you can see, um, it's very similar, right? This is also a good website to look at, Mod the Machine. And this guy, I think it's over here, Mod the Machine, and he's got a lot of tutorials in there as well if you're in doubt, or mostly for C Sharp, VBA, and I think VB.NET as well. But we are using Python here mainly because we want to learn easy, make it easier to learn. And then obviously, if you want to really want to dive into the API development side of things, it's better for you to learn like C Sharp or VB.NET, which is slightly more easier, I would say, in terms of the naming conventions. Because in when we're using Python, there is a slight workaround like how we use the numbers for part definitions and things like that. But anyways, I was digressing. So let's just go back to what we were talking before. So we were talking about component definition, object, component definition object. So it should be inside the part. So let's go back into part. So again, as a recap, so we have the application object and the document object. In the last video, I told that it sits inside application object. This is just for you to form like a mental model. But mainly what's happening here is this is the object hierarchy. So each object here inherits from the previous object. So basically that is a parent object, and then there's like a child object. So if you can think like the box analogy I gave in the previous video, that there's a bigger box called application, and within that there are like little boxes called documents, and within documents there's another box called part document. So this is like what we call as the object hierarchy, and within each box, which is technically a collection of objects, within each box you'll have different collections, and each will have specific methods. And the whole process of why we're using Python here is to just make it easy for us to understand this API. So because Python is fairly a very easy language to learn, so that's why I chose this one. But anyways, so we are looking at part component definition, right? So if I wanted to do a sketch, let's say a sketch, so it should sit inside part component definition. So let me just check sketch. So there are 148. We just need the one inside part. So it's bringing eye, feature, drawing sketch, planar sketch, sketch blocks, and the likes. So we should find sketches in here. But before we go in there, we just need to look at part component definition, right? So we need to create a reference to the part component definition. So let's do that now. That is my yep, and this is what this is. Okay, that's fine. So part component definition. So we are creating set a reference to the part component definition. So we can say part component definition is basically inventor part document object that we created here, and then we're going to call component definition. So if you see the object model here, so it is called part component definition. But why did I write component definition instead of part component definition? Because that is just the naming terminology in Inventor API. Can't speak this morning for some reason. Yeah. So yeah, part component definition is basically what's happening is, so inside documents you'll have part document, correct? So you will call document, documents, and document, and inside document you have part component definition. This is just for us to understand. You just need to remove that part, the word part, and just use the rest of it. So for example, so let's look at another example. Part component definition is like a classic example. So I'll explain this further as we're like making more and more parts here. So part component definition, and then further in, sorry, I can't find a good example right now. I don't want to waste your time anyways at this point in time, but we will carry on creating the uh, what was I saying, the part using Inventor and Python. So if you want to know what's inside part component definition, what you can do is you can check like print component definition. So on a print part component definition, it'll tell you that it's an object. So because we're going to run this again, it's going to create another part of space. If you want to negate that, what you can do is you can, instead of adding a new document, we can just say this is just for testing purposes. The part document, right, is equal to inventor object dot active document. Again, all these methods are in there. So if you go back in here, so you find active document somewhere here, inside application active. I just know it from using it. This is something you'll use a lot. So active, we don't have it. So, yeah, if we wouldn't have active here, because active is active document is, I think it's a method, correct? So again, as a recap, let's go into the help module. So go help, the programming API, and then go into index and just type in active application object. is there anywhere called active document. So basically what active document does is it gets the active document. So here the active document is the part. So the active document is a part. So what we're gonna do is we're gonna get the active document, and then before we even mention any of these, so let's just test this out. Print inventor part document. Let's print it out. Let's see what. So yeah, we're getting the active document. So this one here. Otherwise, it'll just keep creating new part if you don't do this. I've just commented it out, but we can uncomment it once we know what we're doing with this component definition, so we can test that out again. So let's uncomment this and then print out what is part component definition. Again, it's a com object, so it is telling us that it's a com object. So if you want to know what are the different um, methods that are available inside of uh, the part component definition, what you can do is you can type in dir, right, and then it'll give you a list of all the available methods. So as you can see here, we have analysis manager, annotation, planes, and application, everything. Whatever you can get from within it, you have it. For example, so you have like part component definition has a document method. So these are all the methods inside available, right? So what we are looking for is right now we are trying to create a like a parameter, correct? So we need to like add parameters for for length and what we're going to do here basically. So we have to, what we do normally is basically pick a plane and then we would draw the sketch like explained in the first video, correct? So let's do that now. So let's start creating a sketch and then we'll try to you know extrude the sketch as well. Yeah, so what are the different things that we need? So um okay, so what yeah uh, sorry, I was just looking at my notes over here, and yeah, just bear with me. And so what we're going to do here is yeah, let's look at so we know that that is part component definition. So let's start creating the actual model. So in order to create sketches, first we need to pick the plane. So XY, so in this order, so one, two, three, right? So these are the three planes. So this is plane one, plane two, plane three. So let's create a plane. Let's create a sketch, a reference. So okay, so uh, let me write my notes here. Create a sketch. So in order to create a sketch, let's call it. Let's assign it to the variable. Or even before we're doing that, let's just say part component definition, and retaining the sketches object, right? So where did I find the sketches object from again? Now this is an object, so we have to go look at um, the inventor object model. So let's go and search for sketches, which is a collection object, right? As you can see, we have 3D sketches, drawing sketches. So what we're looking for is planar sketches, correct? So within part component definition, there is the sketches object, yeah, and then we have so we have to add a sketch to it. Basically, we have to add to this collection that that is going to be a sketch. So we have to let inventor know that that is going to be a collection. So how we do it, we we always add an object into it, right? So in order to do that, I'll explain more. This will become more and more clear as we start to build the program. So we have the sketches, collection objects. So what does sketches have? The sketches, we need an add method. So I know that from experience that there is an add method, but if you want to double check, you can always go into the Inventor API and look for sketches object. So the planar sketch object is what we're looking at, right? Or sketches, to be working with sketches. No, that's not what I'm looking for. Sorry, let me type this in the index. Sketches. Yep, sketches. So let's type that again. I keep repeating myself as sketches again and again. So as you can see, no, this is not the one. Not planar sketch. Locate for please. Derived part component object. Derived part component proxy object. Let's look into part component object. Sketches enumerator. No, that's not what I'm looking for. I'm not sure if that is a collection called sketches. We just saw there was one. I'm specifically looking for. Let's look at. There's also a lot of sample programs, so you can look into that as well. Phase one. So again, we know that there is sketches in there, component definition sketches, and you have to add to it. So there should be one. Maybe I'm spelling it wrong. Yeah, sketches property. There you go. Let's check each one at a time. Yeah, part component definition object. There you go. As planar sketches. So basically, part component definition dot sketches is also known as planar sketch. And yeah, so inside sketches object, which is planar sketch, like how we discussed here, planar sketches, we have the add method. So if you're using the add method, like how I've shown it here, add, then what do we need? We need one, and we need one argument, which is compulsory, and then we have like a optional argument, which is the use face edges, which is as a boolean. So you say either true or false. So the planar entity as the object, we know that the planar entity is basically, what is a planar entity? It says input object that defines the planar object the sketch is to be built on. So that could be a face or a plane or anything like that. So valid input for this argument includes planar faces and work planes. So if you create any new work plane, so that will be the case. So we know that xy is 3 based on how I explained earlier. So what we need to do is we need to call the work planes object now. So we have to find out from the work planes object. So like, for example, if you want to find out what are the different work planes, what you do is you just look for part component definition dot. So inside here, this all the different collections we had work planes, right? So if you copy that, so we want to know what are the different work planes. So if I just print this out, so this is the workflow usually. So we know that it's an object. So let's say dot, there should be a method called item, and let's say what's item one. Item one is, again, it's a com object item. So let's try name. Probably doesn't have a method called name. So yeah, it does have a method. So yz plane. So we're looking for xy. So let's try 2. So we got the xz plane, which is the second one. So let's try 3. The xy plane, which we know, which is the, so 3 is the xy plane, which is the plane which we want. So we take this information and we want to add a sketch. Apologies. We want to add a sketch to, so we uncomment this. So we want to add a sketch to this plane, which is the xy plane, right? And then we don't need to add the boolean, which was like a optional argument in the end, right? So we don't need to add that, so we just leave that. So let's say, so we are here, so we've chosen this xy plane, correct? So next, what we have to do is, in order to start sketching, we have to create another object called transient geometry. We need one of these to start creating actual sketch. So we've picked the plane now, and we've added that plane. So basically we've added this plane to the sketches object model. Now we have to start actually sketching in the model space. So in order to do that, we create something called a transient geometry. So this geometry is going to be in transient some space, right? So let's call it tg equals. So this has to be, you have to capture this from the Inventor application itself. So, and the actual name is transient geometry. I believe this is correct. Let's find out. So because this is a collection, we just go check here. Yeah, transient geometry, and it's definitely inside the application. So the application object. So it follows that hierarchy. So you have to go application and then transient directory, like explained earlier. So we go Inventor application and then transient geometry. So if you're in doubt, always print it out to see if it is working. GG, yeah, it says it's a COM object, so we know that it works. So there's not going to be any error. So now what we have to do is we have to start sketching lines. So he's already done a sketch for us here, but hasn't put anything in there because I ran it. I haven't put anything in there because we didn't define any points or lines or nothing. So we need sketch lines, and we're going to add this 2-point rectangle. So in order to add 2-point rectangle, we need 1 point. Like if I were to add a rectangle, so I need 1 point here and another point there, and this is defined by uh, the starting point and the ending point. So that's what it's going to be. But at the moment, so let's just delete this sketch here, and I'll just run the program again, and you'll see a new sketch being created in this model space. See, a new sketch was created, so we'll delete that again. So now what we're going to do is add a sketch to this transient geometry. So this is done in runtime, so we don't need to like assign it to a variable or anything. We can just start typing what we need. So we need sketch, which is the sketch created here. Okay, so we need to add a sketch to this plane. So let's name this sketch. So now we're going to be using sketch, right, which is the return value of this expression here. So sketch dot, so again there is a collection called sketch lines, which can be found again in here. Sketch lines, right? So you have sketch lines, which is a collection. And let's go back to the also sketch lines dot. So this is a method. So if you want to find out what method is available, again, either you can do print or you can go back to the API and type in sketches, sketch lines, sorry, sketch lines. Sketch lines is what we need. Sketch lines, sketch lines, sketch lines. Yeah, sketch lines object. So go to this sketch line object, and you know that we're looking for add as 2-point or add as 2-point centered rectangle. So they're using a 2-point centered rectangle. So the first point is going to be a center. So let's use this one. It's probably easier because we can choose origin as the center, right? So how have they done that? So we have the syntax here. So you go sketch lines dot add 2-point center line, which is a method, and inside it we have two arguments which are mandatory. So we need the center point as the object and center and the corner point as the object. So let's copy this method, go here, add 2 points. So we need the center point now. So how do you create the center point? Center point, it needs to be done in the transient geometry space here in this area. So we have already mentioned tg dot, there's a method called create 0.2D, which I know from experience, but I'll show you how to find it again. Sorry, this is a method, so close the help API. So if that's okay, no problem. We'll go open it again. That's actually here. So sketch lines object, add for 2 point rectangle, and how do we need center point? So we need transient geometry. Transient geometry object. So we have a so we need to create 2 points, right? So can you see, anybody spot 2 points over here? So just go down, go down, go down, create TW. Let's go from the bottom. Create point, create point 2D. Let's look into it. So transient geometry, create point 2D, x coordinate, and it needs a y coordinate as point 2D. Okay, so it needs basically x and y. So let's use this method. Let's go back here. So TG, which is transient geometry, create 2 point. So add this method, and we need x is 0, y is 0, and we would also need so we need to do for the corner one, right? So this is the starting point, and this is the corner point. So we can do the same for corner. So the starting point, corner point. So corner point, we can add it as 80 and 30. Okay. Inventor by default adds everything in centimeters. So if you type 8, it means 8 centimeters. But because we want it in millimeters, we've set our template as millimeters from here. We would need we will be using 8 and 3, which basically is divided by 10, right? So let's see what this does. So let's run this code. Okay, so it's got a sketch, and it's basically drawn a rectangle here. Can everybody see? Okay, let's measure this. Yeah, as you can see, it's done 160. 160 as the length. Okay, what is this then? 60. So it's almost like times 20. It's done it. So we've given 8 and 3, but instead it's given 60 and 180. We'll look into this. But basically, that's in a nutshell, that's how you create a sketch. But I will fix the code. Yeah. So let's just close everything and cancel. Just close it. No. And we'll try to run the code from beginning, right? So now we'll create a new part document from beginning. So let's do this. We'll comment this out. We don't need to print document. Anything unnecessary, we'll just comment it. So basically, if you had like a little hash in the front, you should be able to comment it, or control forward slash in in Windows. That's the shortkey. So let's just run this. As you can see, it did everything like within a fraction of a second. So that's the power of automation. Let's measure this again. Let's go inside the sketch. Measure this again. It's 160 over 60, but we wanted 80, right? We wanted 80 by 30, as we've given in our code here. No, it's actually done. It's actually done what it needs to do. Basically, it's correct what it is done. So it's gone from here to there, which is 60, which is 80. Okay, and there to there, which is 60. Correct. So we've done a center point rectangle anyway. So okay, so that's fine. So that's the end of this video. I hope you guys enjoyed it. Sorry for making it a bit long-winded, but anyways, if you guys liked it, please do like this video.